So what we're doing to start out is you have your sheet here. I want you to take your protractor that you have, and I'm going to want you to bring you to the back. I'm just going to want you to measure two things. So you see on your sheet there's a chart here. There's something called a central angle. A central angle is going to be the measure of this thing here, going from the center out, right? So if you were to measure this triangle, for example, you would figure out that this is 120 degrees. If you do it your rectangle, which is supposed to look a heck of a lot better than mine, if you took your protractor, again, mine, that's not a good drawing here. So bear with me, right? I'm on the confines of the computer. I was able to make your sheet with rulers and stuff. Take your protractor, put it up flush against the line, right? Nice and flat against the line. And what you're going to do is you're just going to measure 10. And in color. So yeah, when you measure this angle here, you should eventually find out that it is some type of an angle. And what did you get for that? You got 120 for it? What you should actually get is you should get about so are you doing the triangle or are you doing the rectangle? Oh yeah, for the triangle you'll get 120. And what would you get for this rectangle here if you did that? Sorry? About 120. Oh, it's about 120 on the rectangle too? Yeah. Oh, maybe I should have done a square there. Try out the sorry? Yeah, I'm just trying to draw a little bit straighter line so I can demonstrate a little bit better. It's kind of unfortunate I'm limited by my technology. Insert shape. Polygon. It'd be 120, 120, 120. Yeah. I'm just trying to load up my stuff here. Oh, this thing. Here we go. Much better. Bring to the front. Okay, so if you have this, so if you're looking at the that 5-sided shape here, because there's 5 sides, it's called a polygon. Same thing. If you're trying to get that interior, figure out what that interior angle is, take your protractor, line it up nice and flat against one of those lines, put that middle part in with the center. So it should look something like this. Erase all ink on slide. And yeah, so now so we're measuring this angle right here. This is what we're measuring. This thing I'm drawing in blue. So if I go from 0, so I can see I go from 0 to 10 to 20 to 30 to 40, 50, 60 to about 70-ish degrees there. I know it's kind of hard to see because of the blue there. It's very small. So in this case, you should get something pretty close to 70. Yeah, well, it's not super straight lines, but that's another case. So. Oh, and there's 75-ish. Yeah, it worked me out slightly different just because I had a hand draw the line. I don't think these were ruler. I think it was a ruler, but it's still going to be like super precise. Like within a degree or two off, that's pretty tricky there. So what I want you guys to try and do here is, I just want you, I'll give you the values after. So just make sure you're using like pencil or something for now. But what I want you to do for just this exact moment is, I just want you to try and measure. These are called the central angles of all of those shapes. I will give those to you in a second. So try and find the central angles. I'll give you the actual exact values in a minute. So just get as far as you can. I'll give you 2 minutes, get as far as you can there. So I'm going to align my protractor with my shape here, make sure it's all nice and flush. I'm going to bring this center line of my protractor to the start of the angle I'm trying to measure. So you see how I've kind of lined up. I've lined up these 2 points here together. So now what I'm going to do is I'm just going to, I'm starting at 0 degrees. I'm just going to measure it out until I get to this line here. So I'm measuring out how many degrees this arc here is. So if you do that, what do you actually get? 50. Yeah. Sorry. So if you add all those up, so first off, you already figured out that it's sorry, what did you guys say it was? Yeah. I don't know what circle. So what you want to do is we want to get our center flush and then bring that center arc to the line. Yeah. Yeah. So I measure from what am I going to do? Yeah. Sorry? Well, you could add them up, but you could also think about it like if this is an identical shape here, you add all 5 of those up, or if you multiply it by 5, you'll get a figure here. So what I actually, oh my gosh, what I actually want to do here, discard that. I'm going back up to my shape here. So it's just because we're going a little bit slower than I would have liked. We started a little bit later than I would have liked. What I'm going to do is I'm just going to give you guys this interior angle here. I want you just to recognize the pattern here. So where I get this number is I'm taking all the angles and I'm just going to add it up. If you were to measure this angle right here, the one I'm drawing in blue, that's 90 degrees. 90 degrees times there's 4 sides. 90 times 4 gave me 360. That's where I got this from. For your pentagon, what you're actually going to have is you're going to have 540 degrees. If you measure all 5 of these angles and add them up, you should end up with getting 540 degrees. If I go to my hexagon, you'd get 720 degrees. Stop me when you see the pattern that's happening. So is this like 1080 kind of thing? Sorry? It's kind of like 1080. No, the snowboarding 1080. Oh, well, that's how that's where that comes from. Yeah, this 1080. Yeah. Yeah, my octagon would be 1080. Now, is anyone seeing the pattern here? How much is this going up by every single time? Yeah, it's going up 180 degrees for every single side you add, right? So when you start at a triangle, you have three sides, 180 degrees. Every time I start adding on a side, I'm adding 180 degrees in total to that shape. And so that's a rule that's going to continue throughout. So same thing with a nonagon, you'd add a 180 to this. All of a sudden I'm at 1260. Same thing, I'm going to end up at 1440 here. Now, if you notice, I don't have an 11-sided shape here. I'm going to skip that. And this one's going to end up straight at 1800. If there was an 11-sided shape, it would be 1620 degrees, but I don't have one on that paper. It's an annoying thing to draw, so I've not included it. So both of these angles, your central angle and your interior angle, they follow a certain type of rule. Your central angle, you take 360 degrees, you divide it by how many triangles you can make, how many sides there are on that thing. So for your central angle, take 360 degrees, divide it by how many sides. Now, this formula right here, this is for your interior angles, for those corners of each thing. There's a more complicated formula. It's 180 degrees, and you times that by the number of sides there are, take away 2. That's a lot harder to say than, hey, you notice how when we have a triangle, it just goes up 180 degrees once we get those 3 sides. So this -2 thing here, that's the mathematician's way of saying this doesn't make sense until we get a triangle. If you have a 2-sided shape, it doesn't make sense.
So like so n equals 6. That makes sense.
Yeah, so if you had a 6-sided shape here, for example, right? If you had your hexagon here, you know it adds up to 720 degrees. So how you do this is you have 180 degrees. You don't have to write this down. We'll go into this in a second. You times that by, there's 6 sides. Take away 2 of those sides.
Oh, okay. Sorry, yeah.
Yeah. So it's 180 degrees times 4, because that's what that ends up giving you, right? Which gives you that 720 degrees. So most people, they get confused by the formula, but it makes sense to them when you see that, oh yeah, you started a triangle and you just add up. That's where that -2 comes from, is because it just counts for the fact that you can't have a shape until you start with a triangle. So what I'm going to do is I'm just going to really quickly 11. Oh, what is that called again? I'm going to Google it because I don't remember. I'll show you what it looks like too. Nonagon is a 9-sided shape. Now an 11-sided one. An 11-sided shape is called a hendecagon. Hendecagon. Hen, yeah, H-E-N. Yeah, hendecagon. This one right here. Microsoft can't draw them, so I didn't want to draw it by hand, so I skipped it entirely. But so what I'm going to do now is we're gonna put this away. This is just kind of like a cheat sheet here, just to kind of, you know, help put some real shapes into play there. These formulas, however, are what we're going to be working with today. So let me bump up this thing right here. So what we're going to do is we're going to go to our last unit. We're going to go to page 203. That is the regular polygons. Where did I put my sheet? So we're going to go to page 203. Here we go. So a polygon is the fancy word for saying it's a shape. A polygon's a shape, okay? That's just what it is. It's any shape you can think of. Any shape you can think of except for a circle is a polygon. So they have a really fancy definition here. It's a shape. A triangle, a rectangle, a hexagon, a stop sign. They're polygons, okay? That's what it is. It's a shape. Now, what we were just working on, everything except for that rectangle, if you remember, everything except for this rectangle here was what's called a regular polygon, because all of the all of the sides of it were equal in length. All the angles were the same. The sides were the same length. The angles were the same length. So these are called regular polygons. This right here, this is a hexagon. This is a regular hexagon, right? Because this side's the same as this side, same as this side, same as this side, same as this side. This angle is the exact same as this angle, as this angle, as this angle, and this angle. It's a regular regular hexagon, regular polygon. So what we're going to do is we're just going to jump straight down 2 pages. We're going to jump straight down 2 pages to question 1. Now you're going to need this sheet at the same time. You need this sheet at the exact same time. So you'll be looking between both of them. So what we have here is, I just have a question here. So Melanie says that since a dodecagon, if you remember, that is a 12-sided shape. They have a 12-sided shape there. She's saying that it has twice as many angles as a hexagon. Right? And it does. There's 12 angles in here, whereas a hexagon only has 6 of them. So I'm just going to write 12 there because it's a 12-sided shape. Hexagon is 6, just helps keep us organized. So what she's saying here is that, hey, because it has twice the number of angles, right? 12 angles versus 6 angles. She's saying that the angles in that dodecagon will be half that of the hexagon. It's a very complicated word problem. I don't actually like it very much, but these are the types of things you'll be seeing. All we really need, though, is we just want to calculate the size of the angles, specifically the central angles. Just make sure you write central in here, of these 2 shapes. So what this question is actually asking us is calculate the size of the central angles of these 2 shapes. So I'm going to start with my 12-sided shape here. I'm just going to write 12 on this left side, just keep organized.
It's called central angles?
Yeah, it's supposed to be central angles here. They didn't specify. It should always specify. So if I want to do the central angle, I'm just going to flip back to my other page here. Remember, central angle it's the one from the center, right? It's in the name. This one.
Central or central?
Central.
Oh, maybe.
So it wants to measure the central angles of this 12-sided shape and the 6-sided shape is what it happens here.
Would it be 60
So I'm just going to use my formula up here just so we get it. So if I want to find the measure of a central angle, I take 360 degrees, I divide it by the number of sides, right? So 360 degrees, there's 12 sides in this shape. Each of those is going to then be 30 degrees, right? That's what that's saying. Each of those central angles is 30 degrees.
So 1 times 6 equal to, or is it 12?
Oh, this one here? It's just divided. This is divided.
Oh, no. That's 2.
Oh yeah, you were thinking the interior angles. Yeah, yeah. Which we'll do in a second. But if I'm doing central angles, just take 360 degrees. That's how many is in a shape. Divide it by however many sides there are. There's 12 of them. So same thing for the central angle, right? There's 360 degrees. Now I'm dividing it by all 6 sides. It's going to be 60 degrees. Absolutely. And that's it. So we've calculated the size here. I just want to go back to this question now. So this person's saying that their 12-sided shape has twice as many angles as the that since the 12-sided shape has twice as many angles as the 6-sided shape, that means the angles are going to be half the size. Is that half the size? Yeah. So you could, we want to verify our conclusion. Melanie is correct. Sure, that's good enough, right? She's right. The angle is half the size. That's it. Now, we've already done question 2. That's exactly what you have on that other piece of paper you were given. We already know that the angles are established.
So should
We-
we just put this in there?
You can if you want. I'm just going to skip it. You're welcome to go back to it if you want. Personally, I'm just going to skip it for the sake of time, but if you want to go back to it, feel free later. But I'm just going to skip ahead and I'm going to go straight to question 3 here. Now, so this is a flower here, right? That's what they have. And so it's asking us 2 questions here. We have to really make sure we read the question carefully because you're going to get asked 2 things sometimes. The first question it's asking us is, what polygon, what shape happens when we join the ends of this flower petal? So I'm just drawing points on each of those ends. Yeah, right? If you connect the dots here, you're going to end up with a pentagon. Those are the shapes that happen when you connect them.
Oh,
Yeah, so you've already answered part 1. So what regular polygon shows up? Pentagon. So that's question 1. What regular polygon's formed? A pentagon. I'm already done that. I'm just going to cross that off. I'm done with it now. The second question it's asking me is, what's at the angle of each vertex? I don't think we've actually talked about vertexes before. Vertexes is just, I'm just going to zoom in. It's this thing right here. It's where the points meet. It's what I'm putting in yellow right here. So it wants to know is, what's the angle at each vertex? That's this thing here. This is a vertex. It's where 2 points meet. That's what a vertex is. Sorry? You're right. It is 72, right? Absolutely. You're calculating the interior angles of something. My formula to calculate interior angles, because you're not going to have this chart with you. All you're going to have is you're going to have these 2 formulas up here. So if I want to find the interior angles, because that's what that is there, it's 180 degrees. You times it by, the formula is n minus 2. What does n mean again? Yeah, number of sides. I have 5 sides. I'm going to put 5 there instead of the n. Take away 2. Again, you don't need to show all of this work. You could just put 180 times like 3. You could just do that. That's fine, right? You know what 5 minus 2 is. I don't need to see your work that you know how to do 5 minus 2. 180 degrees times 3, that gives you 540 degrees, right? Now, here's the thing though. A lot of people would think, oh, I'm done. I found the interior angle. You found the sum, you found all the interior angles if you added them up. The question doesn't want you to add it up. It wants to know what's the angle at each vertex, right? It wants to know what's the angle at each of these things. You know it's going to be the same angle. So how can you find that information now based on this? Divided by 5. Yeah, that's all you have to do. 540 divided by 5 is going to give you 108. That sounds right. 108 degrees sounds right. And then you're done. A lot of people would put 540 degrees and then they'd move on, right? You didn't actually answer the question. You got super close. You were just this far away from it, but you didn't actually answer the question. Now we have each vertex is 108 degrees. We're going to do one more question together. Everyone has that stuff down? Okay. We're going to skip example 2. We're going to skip question 4 because we're actually going to do something like that later in next unit. We're going to go straight to question 5, actually. So we're going down 2 pages straight to question 5. So what we have here is, has anyone ever seen one of these? Like it's so this is an octagon house. It's an octagonal house. 8-sided house is what that is. So this is an 8-sided house. So that's what we have right here. 8-sided house, octagonal house. So it's asking us two questions. One, if this house is a regular octagon, and remember, what does regular octagon mean? What does it mean, the regular word?
I would think like equal size.
You're close. So a regular octagon means that you have an octagon and all of the sides are the same length, all the angles are the same degrees. Equal. Oh, well, you had the sides part, you just didn't have the angles in there as well. But so it's a regular octagon. They would be, yeah. So the question here is asking us, if we have a regular octagon, what's the sum of the angles at the vertices where the exterior walls meet? That's a question that was weirdly worded, right? What that's actually asking you is, if you add up all those interior angles, what do you get? So if you're ever unsure what to do, draw yourself a diagram here. I like doing the top and bottom first. I know it's going to be 8-sided. So I'm just going to go something like this. Oh gosh, that's not good. Sure. Octagon, 8-sided, right? That's where the word octopus comes from, because they have 8 tentacles. Oct is a prefix you're going to need to learn if you haven't yet. Okay, so all it really wants to know in this case is, if you add up all of these 8 angles here, what does it get, right? That's what it's asking you to do. You don't have to ever draw the diagram if you don't need to, but if you're ever unsure, it's a good step to do. So what I need to use here is, I just need to use my formula, right? I'm figuring out the interior angles here. My interior angle formula is this thing right here, up on the top. 180 degrees times number of sides. How many sides do I have? 8. 8 minus 2 is 6. 180 degrees times 6. That's what it is, right? If you add that up, it's 1080 degrees. And that's all you needed for that question, right? It didn't ask what's the size of one of those angles. It just asked what's the size of all 6 angles, all 8 angles added up. You see the sum of angles, add it up. If it asks you for just this one, we've already solved that. We just have to divide this by 6 then, or divide this by 8 then. All right, and then question B is, it's asking us if the front wall of the house is 10 feet wide. So I'm just going to use this one here, 10 feet wide. It wants to know what's the perimeter of the house. Do you remember what perimeter is? So it would be 80. What is perimeter though? It's the area around, yeah, right? It's the length of all the walls. Yeah, this one's not that hard to figure out, right? Oh, this wall's 10. It's a regular octagon. That means all these sides are the exact same. It's 10 times 8. That's all it is. One of the walls is 10 feet. You know, all 8 of those walls are the exact same. 10 times 8, 80 feet. That's the perimeter. Okay, so what I'll do is I'll cut you guys loose there. So what you get for today is you get time for 3 things. One, it's to just finish up these last couple questions here. There's question 6, and then there's some chances to practice stuff. If you go a little bit further below, there is a chapter test that goes over the last 3 sections we've done: triangles, parallel lines, quadrilaterals, polygons. Goes over all 4 of those things. And then you have your assignment that was handed out yesterday. This is the information you need to answer those final 2 questions. That's questions 4 and question 6 that we weren't able to answer yesterday. We now can with this new information. Now I'm going to give you a hint for your concept check. some of those questions come directly from this chapter test, actually. So some of those questions come directly from this chapter test. So if you're able to do them here, you'll do really good on the test as well, or the check as well. So you get time to basically finish up this workbook, to finish up your homework there. The only thing you're going to need to pay attention to is for question 6C, it's going to want you to find the area here. You're going to need the area of a triangle formula. So triangle area. If you remember what that is, your area is just your base times your height divided by 2. So I will cut you guys loose there and let you begin working on that. Please let me know if you have any questions with anything.